20. This is section 4.4, number 7. So let's take a look at 7c, was asked about. And again, it says solve using any method that you choose. So we've solved by graphing. Graph the corresponding quadratic function and then find the x-intercepts. Those will be your solutions. We've also completed the square and solved for our variable that way. We've factored and used the zero product principle, and we've also used the quadratic formula. So any way you choose, this section is quadratic formula, so it might be appropriate to use that. X equals negative b plus or minus root b squared minus 4ac all over 2a. So what is a in this question? A is, well, it's a quadratic, so here's the leading term, right? It's got the squared on the variable. So a is negative 2. B, that would be the number that's on the term that just has a u on it, which doesn't show up here anywhere. So that's going to be 0. And c is going to be the constant, right? That's on the same side of the equation as all the other terms. So if it was minus 16 over here, you'd have to understand that you have to move this over, and c would be positive 16. Okay? So a, b, and c all have to be on the same side of the equation. That's important. Then we just fill everything in. So let's go back to black here. X equals negative, 0 plus or minus the square root of 0 squared minus 4 times negative 2 times 16 all over 2 times negative 2. So that's going to be, we don't even have to keep the 0 there, but what's underneath the root sign there? Well, that's going to be negative and a negative. That's going to be positive. So 8 times 16. Okay, so if you have to do 8 times 16, you want to do that in your head. Do 8 times 10 is 80. 8 times 6 is 48. So this looks like going to be 128. Is that right? Yes. Okay. All over negative 4 on the bottom. So x equals, so root 128. Now, the square root of 128 is not simplified, but we could simplify root 128. Does anyone remember how to simplify radicals from previous math classes that we've had? I remember about simplifying radicals. So we're going to have positive root 128 over negative 4 and negative root 128 over negative 4. So we're going to have two options here, but this 128, this is not simplified. So in order to simplify, what you want to do is you want to find a factor of 128 that's a perfect square, and you want to factor it. So the perfect squares would be, well, here, look at this. We've got two perfect squares here, 16 and 4, right? So 16 is not going to be the largest perfect square, neither is 4. What's 4 times 16? 64. So we actually have 64 times 2, right? 128. So if you take a look at root 64 times root 2 over negative 4, this becomes 8 root 2 over negative 4. And then we can simplify this, right? So that's negative 2 root 2. And this one is going to be over here. By the same logic, is going to be positive 2 root 2. So are those the answers in the back of your textbook there? Anybody do that and check that? Yeah, so those are the correct answers. The tricky part obviously may be the simplification. So if you left your answers here, wouldn't be simplified, and you wouldn't find that in the back of the book there as being the correct answer. But if you simplify that, then you get answers that would match the answer key. Okay. So I'll get you started on number 8 too. I want you guys to work through it. How many of you have done number 8? Yeah. One of you. That's why I'm not going to do it all for you. Okay, I'll get you started though. If anybody else had trouble getting started, but I'm not going to. I won't do the whole question for you. Okay, because I want you guys to struggle through this question. I only had one hand up here out of 32. So, but let me get you started in case you're struggling with that. So to save materials, Coma decides to build, I think that's Coma, to build a horse corral using the barn for one side. He has 30 meters of fencing materials and wants the corral to have an area of 100 meters squared. What are the dimensions of the corral? This is very similar to one we did in the last chapter, I think. Remember that one that was an area question and it involved different length of materials and unknown dimensions. Very similar to that one. So it's going to be the same type of question, and you're going to have new ways to solve that same kind of question. So as long as we get a picture of what's happening here, here's the corral. The area for the corral needs to be 100 meters squared, right? It is going to be looking like it's going to be a rectangle here. It doesn't really say, but I think we can assume that there's a rectangle given the diagram. So we're going to have a width and a length and another width. We do not need to use fencing material for the barn side right here. We don't need to put a fence alongside the barn because the barn will be that that fence, right? So looks like that W plus W plus L would be equal to this total amount of fencing that he has. All right? Now, W and L, if you don't like to use W and L, you can. I would suggest it, but you could use X and Y as well if you want. But this, of course, simplifies to 2W plus L equals 30. All right? Now, the other bit of information, so that's the one equation that we can make. That's the information given the fencing material. The other bit of information is about the area. You see that? Those are two distinct parts of this question. And so we can make another equation using this information. So the area, that's going to be the length times the width, or L times W has to equal 100. There's our second equation. So in these types of problems, what you want to do is you want to create, most likely it's going to be two equations, but ultimately you want to combine those two so that you only have one equation. One equation with one variable. And then you're going to use your various methods to solve for that solution or solutions for that variable. So how do we mix these two together? Well, again, the area one here is probably the one we're going to want to deal with here. You don't have to, but I think it's going to be a quadratic, and let me show you what to do there. So you don't want two variables here, right? You don't want two variables, you only want one. So let's isolate L in the first example. So L is going to be 30 minus 2W. Does everyone see that? That's what L is going to be equal here. We can rearrange our first, and we can use substitution method. So now I'm going to write this. 30 minus 2W in place of the L here, times W equals 100. Okay? So that's what you're going to want to do. You want to use that area part and that equation there. Now, if you wanted to isolate for a variable in the second one and substitute it back into the first, you could do that as well. You could do that as well. It still will be a quadratic, and that will still work, okay? So you could substitute any equation into the other. Doesn't matter. Okay, I'll just backtrack there a little bit and say that. So what's going to happen here? Well, you're going to multiply out, and this is where I'll kind of break and give you a chance to finish this on your own. But what you're going to do is you're going to multiply that out on the left side. You're going to get a quadratic, and you're going to solve for W. Any way that you've learned how to do in this chapter. Probably going to be easiest to use the quadratic formula again. Okay? So I'll pause there. That's the setup. I'll get you to solve for W. You may get two answers, right? One of them probably is going to be not a reasonable answer. You may have a negative length or width. You may have a negative W. Or the W may be too large that, like, what if W was 50? If W was 15, then you have 15 here, 15 here. You've used up your 30. The length is 0. So that doesn't work. So that's an example of an answer that you would reject. So go ahead and finish that. So when you multiply this out, you're going to get 30W minus 2W squared equals 100. If you put everything over to one side, you should get this. Right? And then if you use the quadratic formula, A is 2, B is negative 30, C is 100. X equals negative 30. Quadratic formula. So that's going to be 30 plus or minus the square root of 900 minus 800 is 100. Or 4. Oops, that's W, I guess. So you should get W equals 30 plus 10 over 4. That's going to be 10. Or 30 minus 10 over 4, which is going to be 5. Now what you have to do is you have to figure out which one is going to be reasonable, or both. Both could be reasonable, but you might have to reject one. So for example, if this was 10, if the width was 10, that was 10, and this is 10, we know that the length is what? The length is going to be what? Well, 10, it's going to be, the length is going to be 100 divided by W, so the length is going to be 10 as well. Sorry, length times width. 2W plus L equals 30. So sorry, we got to go to this one. L is going to be 30 minus 20. 30, yeah, 30 minus 20. And if W was 5, let's see, 30 minus 10 is 20. So 5. So 5 and 5, 30 minus 10 is 20. Okay? So could these both be correct answers? Do they fit all the logic? Well, the product of the two, the area is 100 for this one, and the area technically is 100 for this one as well. What about the fencing? 10 plus 10 plus 10, and 5 plus 5 plus 20. So the dimensions could be 5 by 20, whatever that is, meters, or 10 by 10 meters. Anybody have any questions about number 8? No? Good. Okay, so for any of you that are interested, just to follow up here, if anyone sees this document here, this is the solution document I found. This is incorrect, actually. So right here, this is correct, but this is not a correct factor of that. This should be a minus. Therefore, this should be a positive solution, so there should be two answers. This is incorrect. So 10 by 10 and 5 meters by 20 meters should be the two solutions. So if anyone sees this solution document on this question and wondering what's going on here, this is actually incorrect, we found out. So.